Hello, scholars. It's me, Mr. G. I'm sitting here with my dog Linus, hanging out, getting some fresh air. And it's time for our daily dose of math. So I hope you're having a great day. Let's get started. If you've been paying attention to the news lately, you've probably heard a lot in the last day or so about the number of cases in the United States spiking. The amount of people who have been confirmed to have the coronavirus, that has been spiking. And this graph does a good job of showing it. This is a graph of the daily new cases. So how many new cases were found out every day? And it starts in February 15th. And as we move through the graph, not much is happening. February 21st, it looks like a little bump, few cases, few cases, few cases. It seems like a small number of cases, and it slowly starts getting more and more and more. And then on March 17th, it jumps up to around just under 2,000. And by March 18th, it jumps all the way up to almost 3,000. So if you're looking at this graph, what I get from this graph is that what it seems like is not many people were being infected with coronavirus, and then all of a sudden, a lot of people were. And we already talked a little bit about exponential growth and why this represents an exponential growth because of the way this graph is curving and climbing up more and more and more each day. But there's something more going on in this graph that I think we need to talk about. It's not just that more people are getting sick. The reason that you're seeing these numbers increase the way they are, and they seem pretty scary when you look at them, is that we're testing more people. As we talked about yesterday, the United States is just starting to get on board with more and more testing. So naturally, the more tests you give out, the more positive results you're going to have. The people who are testing positive on March 18th also most likely were infected with the virus on March 17th and March 16th. The only reason they're not showing up on the graph here is because they weren't tested yet. So over the next few days, definitely should be expecting this number to keep going up and up, the number of new cases. That doesn't only mean that the virus is spreading fast. It does, but what else it means is that we are testing more and more people. And as we said yesterday, the more tests we have, the better off we are. With the more testing is going to come higher numbers of cases. Let's take a look at two more graphs that talk about the number of coronavirus cases and go a little bit deeper into the math behind the graphs. I first want to look at this graph on the left. This is a graph of the total coronavirus cases in the United States. And again, this is total. This is no longer just new cases each day. So it's not telling me how many new cases there are each day. It's telling me what's the total number of cases each day. And it starts at February 15th. And goes on to March 18th. And at March 18th, there are 9,259 cases right now. What you'll notice about this graph is that it has that exponential curve to it. It has that steep curve that we said we were looking for when looking at these graphs, because we know that is how this virus spreads. It is not only exponential because it spreads fast, but also because we are testing more and more each day. So we expect to see this shape on this graph. If we take a look at this second graph here, I want to point out something interesting. This graph is showing us the same information. We have the dates down here, and we have the total coronavirus cases here. And we have on March 18th, our total cases are 9,259. But on this graph, if you look at the shape, it almost looks a little bit linear. It looks like we're just going up by the same amount each day. And there's a reason for that. Even though these graphs show the same exact information, one is using what we call a linear scale, and one is using what we call a logarithmic scale. And if you look closely at our vertical axis, you should be able to notice the difference. On this graph, the logarithmic scale, we are going from 10 to 100 to 1,000 to 10,000 to 100,000. So each jump up in our axis here is being multiplied by 10. Is being multiplied by 10. That's not usually what we see when we make a graph in class or when we work on graphing relationships. Usually our scale is the same. The reason that they show this is because they are knowing that this graph is going to grow very quickly. So as it goes up, we have to make these numbers go up more and more. But when you have a logarithmic scale, the results look linear. the results of this exponential growth looks kind of linear. Whereas if we come over here to our linear scale and take a look at our scale here, we start at 0, then we go up 2,500, then we go up another 2,500 to 5, then we go up another 2,500 to 7,500, and then another 2,500 to 10,000. So the scale itself is linear because it increases by 2,500 each time, instead of multiplying by 10 each time. So even though these graphs show the same information, they look different. They look different, and that all has to do with the scale. So when you're reading a graph about anything, make sure you look at the scale before deciding how fast this is growing, because this looks like very fast growth, whereas this looks not as fast. But those are the same pieces of information, just with a different vertical axis, or if this was on a coordinate plane, we'd call it the y-axis. So be sure you are reading the scales when you are reading information. They can be tricky. Let's take a look at our puzzle from yesterday and go over a solution that I received from a brilliant mathematician that I know named Ellis. To remind you what the puzzle was, we have 2 measuring cups. One measures exactly 5 cups, one measures exactly 3 cups. Unfortunately, we need to measure exactly 1 cup of water. So let's see how Ellis did it. Ellis says, you have to fill up the 3-cup container, okay, and put it in the 5-cup container. So I'm just going to draw what Ellis is saying. So I'm going to fill up the 3-cup container and dump it into the 5 cups, which means I should have 3 cups in my 5-cup container. 3 cups. Okay, let's keep reading. You take another 3 cups and pour it into the 5-cup container until it's full. Okay, so we're going to fill up the 5-cup container now from the 3 cups. So we're going to fill up the 3-cup, dump it in here till it is full. And now we don't have 3 in here, we have 5. So our 5-cup is full. And if you look at what Ellis says, this is important because 3 plus 3 equals 6, but there's only 5 cups. So if you try to pour 3 and then another 3, you're not going to be able to fit all 6 cups into here. You're only going to be able to fit 5. And here comes the big idea. So you have 1 cup remaining in the 3-cup container. That is absolutely correct. Makes total sense to me, and that is a brilliant solution. You fill up the 3 cups, you dump it in. You fill up the 3 cups again, you dump as much as you can in there, and you know this will only fit 5 cups. So if you try to fill this with 6 cups and it only holds 5, you're definitely going to have exactly 1 cup left over in here. Great job, Ellis. Great job, anyone else who figured this out. Let's take a look at our next puzzle. You met my dog Linus earlier. I have another dog named Zoe. They are both very, very rich, so I borrowed some money from them. I borrowed $50 from Zoe and $50 from my dog Linus, so I borrowed $100 in total. I bought a calculator that cost $97, and I got $3 in change. So I gave them $100. They gave me $3 back. I took my calculator. I went home. I gave each of my dog $1, started paying them back because I had $3 change, so I gave Zoe $1. I gave Linus $1, which means now I owe them each $49. If you add together the amounts that I owe them, I owe $49 to Linus and $49 to Zoe. That's a total of $98. I also have that $1 left over from my 3 that I didn't give back to them. If I add that, I have $99. Your question is, where did the extra $1 go? Good luck, try not to pull your hair out, and we'll talk about it tomorrow. Finally, we'll end with some positivity practice. And this is one of my favorite quotes. Be the reason someone smiles today. No matter how bad you are feeling, I promise you it will make you feel better if you can make someone else smile. So when you're in your head about feeling negative, if you're worried about what's on the news, if you're worried about something totally unrelated that's going on in your life, some of the best advice I can give you is take a break from worrying about what you're going through, find someone else, try to make them smile. As soon as you do, I promise you will feel better. That's our moment of positivity. Have any comments, please leave them below. And of course, try your hand at Puzzle 4. I will see you tomorrow.